So now we're on to 4.3, and this is all about mixed and entire radicals. This is an extremely important part, as I say every time, but this is a really important part of math because it kind of goes into all of the other types of math. So trigonometry, you're really going to utilize this stuff. Pretty much lots of trig, but it also just goes anytime you're dealing with any sort of square rooting, and you can imagine that's going to happen a lot. So after this, let's check what I should be able to do. So after this, I should be able to express a radical as a mixed radical in simplest form. You should be able to express a mixed radical as an entire radical. You should use the multiplication property of radicals to convert radicals between mixed and entire radicals. And then you should utilize prime factorization to convert an entire radical to a mixed radical, and vice versa. So here, let's look at a very important property of radicals. So pretty much if you have two numbers multiplying each other inside of a radical, and remember our index is just n for now, you can actually take these out, and as long as we keep the index the same, we can multiply them as two separate radicals. So this is an extremely useful property when dealing with radicals. So let's kind of use this above property in our radicals below. So here, use the product property of radicals in the below questions. So here we have square root 4 times square root 3. So in this case, A would be 4, B would be 3. Remember, if there's no number there, we can assume it's a 2. So what I can do is I can separate these things and multiply them as two separate radicals. This is useful because square root 4 here, we actually know that that's just simply 2. So the square root of 4 is 2 times square root 3. So that means square root 4 times 3 equals 2 root 3. Okay, so there we can see us, and we have made this into a kind of a different looking thing, but it still equals the same thing. Okay, let's use it over here. So square root, or this is actually the cube root, so we have a cube there of 27 times 19. We can separate those two things to be the cube of 27 multiplied by the cube of 19. The cube of 27, hopefully you know, because 3 cubed is 27. So that means 3 equals the cube of 27, or the cube root, sorry. So here we can represent this. This should say cube root here. The cube root of 27 equals 3, so this equals 3. So 3 times cube root 19. So when you're writing this, it's really important to show that this is the index very visibly. Okay, so there we've used the above property. So let's go below and let's talk about mixed and entire radicals. Okay, so we can kind of use the above property, that product property, to convert between mixed and entire radicals. So what is an entire radical? An entire radical is exactly what it sounds like. Everything, the entire number, is inside the radical symbol. So here we can give a bunch of examples. Cube root 18, cube root 147, square root 36, so on and so forth. Fourth root 100,000, okay? Whereas a mixed radical is where you have a number on the outside multiplying your radical. So here we could write it as 3 square root 2, or 4 cube root 8, or 7 times the cube root of negative 8, okay? So here, notice, this is a mixed radical. This is also a mixed radical. This technically up here is an entire radical because of the fact everything is underneath the cube. So without even realizing it, you kind of made a mixed or an entire radical into a mixed radical. We're going to learn a little bit of an easier way to do this. So let's move forward. So converting entire radicals into mixed radicals. So we're going to utilize prime factorization. So hopefully you guys really took the time to learn prime factorization because we use it a lot. Okay, we're going to use prime factorization to determine any perfect square, cube, or nth root. Okay, so this is simply where we put any number there. So n, this would be any perfect square. So a perfect square would be like the square root of x, and then a cube would be the cube root of x, okay, inside the radical. So here we have square root of 1,350. So what we're going to do is we're going to try and find a perfect square in this thing. Okay, so I'm going to open up my calculator before I move forward. Let's clear that. So I'm going to prime factorize it like we normally do. So I can divide this thing by 50. So 1,300 of 50 divided by 50, that gives me 27. Now 50 is divisible by 25, and that gives me 2. And this is divisible by 5 and 5. Okay, 27 we can divide by 3 to give us 9, and then divide that by 3 and that by 3. Now, what are we supposed to do with this? Okay, remember, we're trying to convert this into a mixed radical. So remember what that index is, it's 2, okay? In order to do this, we need to first represent our number in terms of prime factors. So we've done this before. In this case, it would be 2 times 3 times 3 times 3 times 5 times 5. So 2 times 3 times 3 times 3 times 5 times 5. Okay. Now, what is your next step here? My next step is recognize I'm trying to square root things. So let's put things in terms of squares where we can. Okay. So recognize 3 times, even though I have 3 times 3 times 3, I just want to be able to group them into 2s. So I can represent this as 2 times 3 squared times 3. So recognize I've conjoined these two 3 squared, or 3's into 3 squared. And 5 times 5 will become 5 squared. Okay, and remember that equals 1,350. So I can use our rule up here. Okay, I can split these up into its prime factors. So let's do that. So this, the square root of 1,350, well, that equals the square root of 2 times 3 squared times 3 times 5 squared. Okay. Now, recognize that I can break these apart, because realize here, anytime you have a number squared inside a square root, that literally just equals a. It's kind of like if you have a cube root of a cubed, well, that just equals a. So what I'm going to do is I'm going to rearrange this into a bit of more that makes sense. So I'm going to make it 3 squared times 5 squared times 2 times 3. So just recognize what I've done there. I've taken 3 squared, put it here. I've taken 5 squared and I put it here. I've taken 2, put it in it there. And then 3. I'm just rearranging it a little bit easier. Okay, and now I'm going to use my rule here. I'm going to separate them in terms of this. Okay, so how can I do that? I'm going to keep the things I wasn't able to group nicely into 2. Okay, so this will become 3 squared square root times 5 squared square root times 2 times 3. Well, and what do you know, like this, the square root of 3 squared, that simply cancels out and just becomes 3. The square root of 5 squared, that simply becomes 5 times, and I can simplify this into 2 times 3, which is 6. And now 3 times 5, well, that gives me 15 root 6. So I've now made it into a mixed radical. So this thing can be represented as 15 root 6. So let's put in our calculator here. So first let's square 1,350. So that's 36.7423 blah, 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 blah. Now if I do 15 times the square root of 6, that's the same number, okay? We can see that it's the exact same number, okay? So these are simply the same thing, they're just wearing different pants. It's just a different form of that radical. okay? So again, that index tells you what you should be trying to group things in. So here I was able to group 2 3s together, and I was able to group 2 3s together. It's a little different when you're cubing. So here, this is essentially, say, group into 3s. Okay, so let's break this down again. So 3,240, let's divide that by 20. Okay, so 3,240 divided by 20, that gives me 162. 20 is divisible by 4 and 5, and then 2 and 2. Okay, so 4 divided by 2 is 2. So now let's break down 162. So let's divide that by 2. That gives me 81. And then 81 is 9 and 9. Okay, and then we can further break these down into 3 and 3, 3 and 3. Okay, so now again, let's represent this in terms of its prime factors, and let's organize it properly. So I'll put 2 3s beside each other, then my 4 3s, and then my 5. So this will be 3,240 equals 2 times 2 times 2, 3 times 3 times 3 times 3, and then times 5. Okay, so I've just organized it that way, right? Now, I'm not grouping into 2s, I'm trying to find perfect cubes. So here, I want to group into 3s. So my first group of 3 is all these 3 2s. So I can represent this as 2 cubed, okay? I can represent this, there's a group of 3 3s here. So this will be 3 cubed, and recognize that 3 didn't go anywhere, we're still multiplying by 3. And then 5 is all alone, times 5. So recognize that 3,240 equals this. So now I'm going to put this underneath that radical. So the cube root of 3,240 equals the cube root of 2 cubed times 3 cubed times 3 times 5. Okay, and these aren't decimals, these are actual multiplications. Okay, and now again, we're going to split it up. Anywhere where we've grouped into 3s, we'll split up into its individual one, and we'll keep these together since they can't really be broken down. So this will become the cube root of 2 cubed, multiply the cube root of 3 cubed, multiply cube of 3 times 5. Okay? This cube root is canceled out by this cube. So this just becomes 2 times this cube root cancels out this cube. So this becomes 2 times 3 multiplied by the cube root of 3 times 5. Now 2 times 3, that equals 6, cube 15. And there is our mixed radical. So let's plug this into our calculator and make sure everything makes sense. So remember how to cube. We're going to press math 4. Now we're cubing 3,240. So we learned how to do that in our last section. So it gives us 14.7927. Now let's go here, and this will be 6 times the cube root of 15. And it's the same number, okay? Because it is the same number, it's just wearing different clothes, okay? We've simply put an entire radical into a mixed radical. Okay, so recognize that. So that's why prime factorization is really useful. We've seen tons of uses for it now. So let's go forward and let's keep simplifying. So simplify simply means, in terms of simplifying the following fractions, it means put into mixed. So it's the exact same thing. So here, remember, this is 2, so the square root of 1,764. So we're going to apply the same thing. We're going to do 1,764, and we're going to divide it by 4. So there you go. That's 4, and this is 441. 4 is divisible by 2, and that makes 2. 441, I'm going to assume maybe is divisible by 3. So sometimes you're going to have to guess. That looks like it might be divisible by 3, which it is. And then 49, well, that's a perfect square. So this will be 7 and 7, because 7 squared is 49. So here, we can represent 1,764 as 2 times 2 times 3 times 3 times 7 times 7. Okay? And now, what do we have to group in? We have to group in terms of 2's. So here, I have 2 2's. Here, I have 3 2's, or sorry, 2 3's. And then here, I have 2 7's. So I can represent this 1,764 in terms of 2 squared times 3 squared times 7 squared. Okay, and then from there, we will represent that here. So the square root of 1,764, that equals the square root of 2 squared times 3 squared times 7 squared. And now we can use our product rule. So this is the square root of 2 squared multiplied by the square root of 3 squared multiplied by the square root of 7 squared. And remember, square rooting something being squared, that cancels out. So I'm left with 2 times 3 times 7. So here it's 42. So what does that mean? That means this thing is a perfect square. Okay, because it just equals 42. So if I go on my calculator and I do the square root of 1,764, we can see that actually just equals a number. Okay, it's a rational number. Okay, it just equals 42. We could also show this by doing 42 squared, right? 42 squared equals 1,764. Okay, so actually simplifying that has showed us it is a perfect square. These guys up here, this is definitely not a perfect square because it shows a mixed radical. This is definitely not a perfect cube because it shows a mixed radical. Okay, let's do one. Usually you're going to mainly just see where you have 3's and square rooting, but sometimes your index might be a different number. So remember, that just means group into 4's. Okay, so let's look at 3,000. So let's divide this thing by 4. So dividing by 4 gives me 756. 4 divided 2 gives me 2. 756 divided by 2, that gives me 378. 378, let's divide it by 4. Oh, that didn't work. So I'm going to actually divide it by 2. There you go. So 2, 189. Let's divide that by 9. Look at that. So that divides by 9, and that's 21. 9 dividing 3 gives me 3. 21 divided by 3 gives me 7. Okay. So now I can represent 3,024 in terms of, well, here I have 2 times 2 times 2 times 2. So 2 times 2 times 2 times 2. And then I will do 3 times 3 times 3. And then multiplied by a single 7. And recognize I'm trying to convert something that's being fourth rooted. So I have to group things into groups of 4. So these 2's can all be represented as 2 to the power of 4. And check this out. I can't break this down. This is 3 times 3 times 3. I can make it 3 cubed, but that's not what I'm looking for. So I'm going to keep representing it by 3 times 3 times 3. And 7 I can't do anything about either. Okay, so now I'm going to place this in for 3,024. So this will be the fourth root of 3,024, and I can represent that as the fourth root of 2 to the power 4, 3 times 3 times 3 times 7. Okay, and then from there, I'm going to take everything out that I can and apply the product rule to my perfect fourths, or powers of 4. So this will be fourth root 2 to the power 4, multiply, and here I'm actually just going to keep everything underneath the same radical because I wasn't able to group into a 4 anywhere. So this will be 3 times 3 times 3 times 7. Okay, and then from there, 4th root 2 to the power 4. Well, that cancels out and leaves you with 2. And then that'll be multiplying 3 times 3 times 3 times 7. Let's plug that in our calculator. So that's 189. So that's the simplest we can make this. Now let's check. Remember, we can always check in our calculator. So recall how to put a 4th root in. We're going to press 4, math, and then you're going to press 5, and it's going to make that number your index. 3024. So that gives me 7.4155. Now let's check my mixed radical. So I'm going to do 2, and I'm actually going to have to really utilize my brackets here. If I don't utilize my brackets, okay, my calculator will end up doing 24th root 188, which is totally wrong. So I'm going to utilize my brackets. Now press 4, math, 189, okay? I'm going to close that bracket on the outside. So now I have 2 multiplying this expression here. Okay, so 2 multiply this entire number, and that gives me the same value. Okay, so you can see that there. So you've been able to check your answer. Okay, so this is a really important part of Math 10C, so please practice it and do practice problems figuring out different scenarios. Okay, so let's move forward and let us look at going the other way. So we just learned how to make an entire radical into a mixed radical, right? These are entire radicals, these are mixed radicals. How do we go the other way? Well, the other way isn't as difficult, okay? You're going to use indexes to place the outside within a radicand. So recognize what we're doing here. We just talked about how having a square rooting, that cancels it out. Well, we can kind of go the other way. We now know that 4 equals a square root of 4 squared. So now we can put these things inside of our radicals. So let's look here. Right here, you're talking about an index of 2, right? 3 square root 2. So what I'm going to do is, in order for me to be able to bring this inside, I need to represent it as a radical. So this will be the cube root of 3, or sorry, not the cube root, the square root. The square root of 3 squared, because remember, square root of 3 squared simply equals 3. So there I've represented as a radical, multiplied by the square root of 8. And now I can, since they both have the same index, bring them under the same radical. So this will be the square root of 3 times 8, or 3 squared times 8, which is going to give me 9 times 8, which gives me the square root of 72. Okay, so 3 square root 8 equals square root 72. And again, you can check that. So 3 square root, let's clear that, 3 square root 8, and let's check what the square root of 72 is. So it equals the same values, so that's a way we can check in our calculator. Okay, so let's look over here. 7 cube root 14. Well, remember, in order to bring this inside, we need to make it cubed. So this will be the cube root of 7 cubed times 14. So recognize that index is telling me what to put the power as. Okay, because if we really want to write it out, we can do this, and then we can bring both of them under the same radical since they have the same index. Okay, and what will that equal? Well, let's see what 7 cubed is. So 7 to the power of 3, that's 343 multiplied by 14. So this is the cube root of 4,802. And again, we can check our calculator. So let's plug this into my calculator. 7 math, and then I'm going to cube root 14. That equals 16.871. And let's do the cube root of 4,802. So math cube 4,082, or 802, sorry. And that gives me the same number, because it is the same number, it's just represented in a different way. Okay, so hopefully you're seeing the pattern here, and this one's not as bad as how to do it the other way. So let's make this mixed radical into an entire radical. I need to bring this outside number inside the radical, so it has to be the power of 7. Because remember, 4 equals 7th root 4 to the power of 7. So I can do 7 root 4 to the power of 7 multiplied by 7 root 7. And now, since they have the same radical numbers, I can bring them inside the one radical, an entire radical. So this will be 4 to the power of 7 times 7. And let's plug this into my calculator. So brackets 4 to the power of 7, bracket, times 7. So that would be the 7th root of 114,688. Okay, so it's kind of amazing that this number equals the exact same number as this, right? And then let's do one more here. So again, I need to bring this 2 inside my radical, so I'm going to use my index to tell me what the power should be. So this will be the 4th root, 2 to the power of 4 times 67. Let's plug that into my calculator. And that will be the 4th root of 1072. So there is my entire radical, and there is my mixed radical. Okay, so hopefully we're seeing all of the patterns here. Okay, so practice both ways for sure. Okay, now let's use how we can utilize this in terms of some trigonometry. Okay, and just some other word problems. So here, determine the area of the following triangle, give the exact simplified solution. So right now we only know how to give, well, before we only knew how to give estimated, so we would find decimal numbers using our calculator. Now we know how to find exact because we can make radicals. We know how to work with radicals, okay, and we know how to simplify them. So let's determine the area of this triangle. Remember, an area of a triangle equals base times height divided by 2. Recall that this height is the height from the highest point dropped straight down. Okay, so recognize that this is an isosceles triangle. So this side also equals 9. That's what that line means there. Okay, now this is my height. I have my base. My base equals 14, but I really need to figure out this height. Okay, so what I can do is I can break this section off here into a right triangle. So there is my right triangle I'm dealing with, where here's my height, here's my 9, and recognize this is half of 14, so this is 7 here. And we know how to find this thing. So this is a leg here, this is c, so we can use a squared plus b squared equals c squared. Remember, hypotenuse has to be c. So this is my hypotenuse here, because this is 90 degrees. So this has to equal c. So in order to find h, it'll be h squared plus 7 squared equals 9 squared. And then we can solve for h. So I'm going to subtract 7 squared from both sides, and I'll get h squared equaling 9 squared minus 7 squared. Now h squared equals 9 squared is 81, 7 squared is 49. Okay, now let's maybe pull out our calculator here. So 81 minus 49, that gives me 32. And now I need to square root this. So let's square root both sides, and we will get h equaling the square root of 32. Now recognize that we don't want to put this in our calculator because we want an exact value. Okay, if we plug that into our calculator, square root 32, you get a really ugly decimal number. We're not looking for an ugly decimal number. We're looking for, as our question said, an exact simplified solution. So the first thing I'm going to do here actually is simplify this, okay, aka put it into a mixed radical. So let's put this into a mixed radical. So 32, let's divide 2 here. So 32 divided by 2, that gives me 16. I'm going to divide 2, that gives me 8. Divide 2, that gives me 4, 2 and 2. So here, I can represent 32 as 2 times 2 times 2 times 2 times 2. So let's do that. 2 times 2 times 2 times 2, 5 2s, right? Let's count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Good. Now remember, if there is no number for the index, you can imagine a little 2 there. So this means I have to group things into 2s. So there's my first group of 2s. Here's my second 2 grouping of 2s, and then I'll have 1 left over. So I can represent this as 2 squared times 2 squared times 2. And you can see here that this has become 2 squared, and this has become 2 squared. Okay, and then I can use my product rule. So this will become 2 squared times root 2 squared times root 2. Our square root cancels out this square, so this becomes 2 times root 2. So that will be 2 times 2 is 4, root 2. So this is the simplified version of square root 32. And remember, we can check our solution. Let's plug this in our calculator and make sure everything makes sense. So we can see that these in fact do equal each other. So I'm going to use this for h. So h equals 4 root 2. Okay. And now I can figure out the exact simplified solution. Okay. Because I don't have an estimated calculator value here, I have an absolute value here. I have the exact solution. So here I'm going to plug b in for 14 and h in for 4 root 2. So this will be 14 times 4 root 2 dividing 2. Now 14 times 4, let's see, we could use our calculator there. 4 times 14, that gives us 56 times root 2 divided 2. And it's important to understand that you can't square root, or you can't divide this 2 by this 2, because that makes no sense. This 2 is being square rooted. That's a different number being divided by 2. So what I can do here is I can take 56 and divide it by 2, because it's not being applied to a radical. So this is 56 divided 2, and that gives me 28 root 2. So there is my area. The area of this triangle, equals 28 root 2 units squared. We weren't given any units here, so you're just going to leave it as units squared. Okay? So that is our solution. Let's maybe go down. So this is really important to kind of understand. So make sure you're doing lots of practice problems, because it can be kind of confusing at the beginning. Come in and ask lots of questions if you are feeling a little confused. So let's do one more. Let's look at example 6 here. So a square has an area of 252 meters square. Determine the side length of the square in simplest radical form. So remember what a square is. A square is every side length is the exact same. So if this is x, this is x, this is x, and this is x. So this is a square. The area of a square is simply base times height. And in this case, your base and your height are the same values. So it'll be x times x, and that means it's x squared. Okay, so we have area equals x squared for a square. Okay, we have the area here. This is the side length. X equals side length. This is what we're trying to find. So let's solve for x. So here we get 252 meters squared equals x squared. In order to solve for x here, we have to square root both sides. So this will be the square root of 252 meters squared equals x. Now again, we can't just simply plug this into our calculator because it wants the simplest radical form. So here we're going to have to prime factorize. So let's break this down. So I'm going to divide this by 2, and let's pull up the calculator and start figuring out what the solution is. So 252 divided 2, that gives me 126. Let's divide 126 by 6. So 6, and that gives me 21. 6 dividing 2 gives me 3. 21 divided by 3 gives me 7. Okay, so I've prime factorized. So let's kind of bring this over here. The square root of 252 meters squared, I can represent that in terms of its prime factors. So here I could represent it as the square root of 2 times 2, 2 times 2 times 3 times 3 times 7. Okay, so again, I took all these values and I multiplied them together here. Now, in order to make this into a mixed radical, I need to group depending on what my index is. So my index again is 2. If nothing is there, it's 2. So I have to group these things into groups of 2 with the same numbers. So here, hopefully you can see that I have 2 2s, I have 2 3s. So I can represent that as 2 squared times 3 squared times 7. And then I can use my product rule. So this can be 2 squared, root 2 squared times root 3 squared times root 7. My square root is canceled out by my square, so this is 2 times my square root is canceled out by my square, so this is 3 times root 7. And then 2 times 3 is 6, root 7. And this would be, now check this out, this is kind of interesting. This meter squared, this would have followed along here. Something to note though is you could actually take this out and you can square root that squared. So this is just the square root of m squared, well that equals m. And that's where your meters come from when you square root something. Okay, so this is my side length, 6 root squared. Now, in our calculator, if they asked you just for the decimal, we simply would have taken the square root of 252. You learned that in like, what, grade 8? So F roughly equals 15.874 meters, but the actual value is 6 root 7 meters. Okay, and if I do 6 root 7 meters, now if I plug that in, we can see it's the exact same answer. Okay, so make sure you come in for lots of questions if you're feeling confused, and give lots of practice problems, okay? So if you want other practice problems, please send them my way. There's some practice problems you can try. Go check out your understanding with AFL 4.3.